Hello guys, welcome back to the automation revolution. In this video we are going to discuss about distributed control system. So for the beginner I will request you to please first learn about PLCs, karta and HMI. So it will be very easy to understand distributed control system. So let's start first basic definition of DCS system. So distributed control system or DCS is actually a control system for any process or plant where control elements are distributed throughout the system or network. It's differ from centralized control where the single controller or any its central location handle the total system, but in DCS and every system or every process elements has its own dedicated controller. Second thing, DCS is consist of large number of local control and all control have different communication protocol. So it can be Profibus DP, Profibus PA, or it can be industrial Ethernet or Profinet. What are the applications of DCS? So mainly in oil gas sector, all process industries, whether it will be continuous process or it can be control manufacturing process like oil refining, petrochemicals and power generations, fertilizers, pharmaceuticals, food and beverage industries, cement production, steel making. So in every process industries, mostly DCS control system are used. What are the basic elements of DCS? So engineering station, operating station, automation station, field bus, plant bus or terminal bus. These are the mainly elements of DCS control system. So that we will see in next slide in detail. First of all, we'll see this network view of DCS system. So at top side we have engineering stations. From the engineering stations we can generate new project, we can make programming for our automation station, and hardware configurations can be done with the engineering station. This engineering station has dedicated software for parameterization and programming or making documentations with DCS system. This engineering station and this automation station are connected with plant bus. So this plant bus we are using mostly Profinet or industrial Ethernet. So from the automation station, this automation station is master control or dedicated control, and from this automation station we have connected this coupler with Profibus TP, and from the coupler we have connected this field devices with active field splitter or active field distributor. So that are the networking devices that we'll see in next slide. So you can see here we have used different communication protocol like ASI interface and HART interface, Profibus TP, okay, and we have also used Profibus PA and DP. So these are the distributed control systems. Also we have used distributed IO system and Simocode kit. So throughout the network we have different communication protocols and different networking devices, and all are connected with main automation station. And with automation station we can connect HMI or operating stations for monitoring and controlling the process. So first of all we'll see engineering station. So this engineering station is actually it can be PC or any other computer. From there, from the engineering stations we can configure hardware and we can generate a new project. Also we can create various input and output logic, modifying sequential and continuous process control. We can configure distributed devices, and you can prepare documentation for input and output. So engineering station is one type of PC. From there we can it's have dedicated software, and from there we can make downloading for programming and hardware configuration. Second important thing or element is operating station. So operating station is actually used for operate and monitor the control plant parameters. It can be PC, HMI or any other monitoring device that has a separate software tool, and which operate view process parameters according to the take control action. And OS station can be single unit or multiple units, where single unit performs functions like parameter view display and trend display, alarm, and process control with real-time application. So this will be operating station like that. So different station can be placed, and from the stations we can monitor process in real time, and different screens are providing graphical representation for the process with trend alarms and process parameters we can monitor from this operating station. Now automation station. So this automation station is any controller or hardware from for performing the logical task like PLC, but here it will work as a master control, and this automation station has more capacity as compared to PLC. PLC can handle up to hundreds IO, but this automation station can handle thousands of input and output. It registers a process variable from the connected distributed IO, or it can send data with to input and output. It supplies the operator station with data for visualization, and it registers the actions on operator station for forward them to the process. So here we have this automation station. So right now this is the power supply, and here we have Siemens PCS7 Win LCRTX. This is Siemens automation station, and this automation station we can connect with distributed IO system. So these are the distributed IO, and we have connected with main communication processor, and from this communication processor any plant bus can be connected with this automation station. So that we will see in next video how to configure this automation station and distributed IO. Distributed IO or remote IO. So it can be placed near to field devices where sensor and actuators are connected with system, or certain locations where these field devices are connected via communication link. It receives instruction from engineering station like set point and other parameters directly control field devices. It can sense and control both analog and digital input output by analog and digital input output module. So these modules are can be expandable according to the number of input and output. It can collect the information from the discrete field devices and send the information to the operating station or engineering station. So here you can see these are the distributed IO system. So based on applications we can select this number of input and output. So this can be discrete or analog, and all input and output can be connected in serial, and from there all input and output IO can communicate with this communication processor. So this, we can say extended terminals or CP card, and from this communication processor we can connect this automation station. So by this Profibus cable or plant bus we can connect both automation station and distributed IO. So these are the distributed IO can be connected in field area, and from the field area we are sending the data in automation station. Field bus or plant bus and terminal bus. So field bus is communication bus from field device to device coupler which are installed in the field area or potential explosive area. Plant bus is communication bus from device coupler to automation station or operating station for supervisory monitoring level. So in field bus mostly Profibus, PA, DP, that type of potential that protocol that can be placed in potential explosive area. So that type protocols were placed in field bus, and in the plant bus high speed communication cable like Profinet or Industrial Ethernet, TCP/IP, that type of protocol we are using in plant bus. So based on application and environment zone we are selecting this communication protocols. System redundancy and field devices. So DCS must have redundancy in order to continue the process. So sometimes in abnormal conditions any device or any controller can be failed. So in that case this process must be continue in real time. So for the redundancy we are using different hardware devices like active field splitter, active field distributor, and active field distributor for potential explosive area. So that we will see in this next slide. So what are these field devices? So you can see based on this environment zone. So for gas we have class 1, and here different zone we have divided. So for gas we have zone 0, zone 1 and zone 2, and for dust we have class 2, zone 0, zone 1 and zone 2. So this is automation station we have connected with extended terminals or distributed IO, and this distributed IO are connected with actuator and sensor. So you can see these two areas, hazardous area or potential explosive area, and based on that we are selecting this distributed IO. So you can see in the normal condition we are using ET 200S, and for this hazardous or potential explosive area we are using ET 200 ISP. So it's used for potential explosive area, and based on this environment we are using this communication protocol. So here we have used this Profibus DP, and here we are using this Profibus PA or any other protocols. So based on this environment zone we are using this actuator sensor interface as well as communication protocols. Now here we are using AFD or AFS. So AFS is active field splitter. So this active field splitter is actually used for making redundancy with this coupler. So you can see here we have connected two DPPA coupler. So when any one coupler will fail, so that time second coupler will be take place for communication, and with the help of this AFS we can connect these field devices with main station or automation station. Here we have used this AFD, active field distributor. So generally this active field distributor is used for connecting field devices with this coupler. So when here we have used this ring redundancy. So when any active field distributor will fail, so in that case coupler can carry the data with automation station. So like that AFD and FS are used for establishing this redundancy in this DCS system. Here we have used AFDIS. So these are active field distributed IS is actually used for potential explosive area. You can see here we have zone 0 and here we have zone 1. So based on that we are selecting this field devices, and all field devices are connected with active field distributor. Here we have connected AFD in ring. So when any this communication link will be fail, so in that case this AFD can carry the information with second link with automation station. Here we have connected AFS, active field splitter. So this active field splitter used for making redundancy with this coupler. So when a coupler will fail, so in second directions we can send the data to automation station or DP master. In last we have Y-link. So this Y-link is actually used for making redundancy with communication link. So you can see here we have this operating station, and this is local configuration tool for making programming or parameterization, and here we have automation station or master control, and with automation station we have made two link, and that two link are connected in Y shape. So you can see when any coupler this communication will fail, so in that case it can carry information via second cable. When this cable will fail, so in that case this second link will send the data to automation station. So like that we can make redundancy for this coupler, we can make redundancy for device field devices, or we can make redundancy for automation station also. There are many other parameters, there are many other uh, things can be placed in distributed control system. So after this we will see very basic thing. Thank you very much for watching the video, and if you have any query or questions you can ask in our YouTube channel. Please share and subscribe as much as to know about this automation revolution. Thank you very much.